Okay, so in this video, we are going to discuss the paper from February-March 2020 and then paper 6.2, which is the statistics 2 paper. Let us have a look for question number 1. Okay, so the booklet produced by a certain publisher contained, on average, 1 incorrect letter for 30,000 letters, right? And these errors occur randomly. We are having a booklet from this publisher and contain 12,500 letters. So we want to use a suitable approximating distribution. Highlight the keyword approximating to find the probability that this booklet contains at least 2 errors. All right, so first of all, we need to know for our syllabus, right? How many types of approximating distribution do we have in A2 syllabus? There are basically 2 types. The first one is changing binomial become Poisson. And another type is we are having Poisson and we go to change it become a normal distribution. So there are 2 types of approximating distribution in our syllabus. Okay, then which one should we apply in this particular question? Okay, so we need to know originally what kind of distribution does this belongs to, right? So I want you to highlight the word or the phrase, 1 incorrect letter per 30,000 letters. So I want you to highlight this one. So this basically tells you the probability of the letter, the incorrect letter can be found. All right, this is a probability. And we are having a total of 12,500 letters. So for this 12,500, you can assume it as an n, which is the total trial. All right, so from here, you're having the total number of trial and also the probability of getting the incorrect letters. So from here, you should know that it belongs to binomial originally. So this also means that we are having binomial to Poisson. Okay, because our original equation, our original distribution is binomial, and we are going to change it become Poisson. All right, so let's have a look for detail, yeah? If I'm having binomial originally, with the parameter n and also the p, I want to change it become Poisson, right? So to change it become Poisson, the lambda that we get is getting from the lambda also have the same meaning as mean, right? So to get the lambda, you are having n times p from binomial distribution to get the mean. Okay, then when you're going to change binomial become Poisson, basically there are some condition that you need to fulfill one. All right, so you can double check and see that. By right, your n must be greater than 50 and your MP must be smaller than 5. So in this question, you can see that, oh, n is more than 50. Definitely n is more than 50. Then if you multiply n with the p together, you check and see whether it is smaller than 5. By right, it should be smaller than 5 because it is the condition that we want to change binomial become Poisson, right? Okay, and then for binomial, it is a discrete random variable. Poisson is also a discrete random variable. Therefore, no continuity correction is needed when you are trying to calculate the probability when changing the distribution. Okay, so let us start the setting out of the question, yeah? So I'm having x is binomial distributed originally, n is 12,500, where the p is 1 out of 30,000. So 1 out of 30,000. And I'm going to change it become a Poisson distribution. Okay, so I'm having a Poisson distribution. And what is the lambda here? So to get the lambda, I'm taking n multiply with the p. So n times p, and you try to simplify it. By right, you'll be getting 5 over 12. This is the lambda. All right, so again, how to get the lambda? You are taking n multiply with p, yeah? So n is this one, 12,500, p is 1 over 30,000. Okay, then if you double check the condition, you realize that the x here, the lambda here is less than 5. N times p is less than 5, which fulfill the condition of changing binomial become Poisson. Okay, so once you change it become Poisson already, then we can start calculating the probability. So what is the probability that we have here? They want us to calculate contain at least 2 errors. So number of error at least 2 means greater or equals to 2, right? At least 2 means that it can be 2, 3, 4, 5, and so on. So when you are writing out the symbol, it should be including the equal sign for the 2. So greater equals to 2. For any Poisson distribution, if you want to calculate the probability, you should have x is the integer. So x start from 2 lah. X equals to 2, x equals to 3, x equals to 4, x equals to 5, and then x to infinity. So infinity is an unlimited number, right? So it is impossible for us to calculate in this way. Therefore, what we are going to do is, I want to take 1 minus the probability of x smaller than 2. Okay, so what is the general formula for Poisson distribution? To calculate the probability x equals to r in the Poisson distribution, it is e negative lambda power r divided by r factorial. Okay, so I want to apply this formula here. I'm having e negative lambda, which is 5 over 12. Okay, then I want to calculate the probability for x equals to 0. So for x equals to 0, I have e negative lambda, I put it outside. So x equals to 0 means lambda power 0 divided by 0 factorial. So lambda power 0 divided by 0 factorial, it is always a 1. Then plus, after that, I want to have the probability of x equals to 1. I'm also having e negative lambda, but I put it outside. Then I'm having lambda power 1 divided by 1 factorial. Therefore, I'm having 5 over 12, which is the lambda. Then I shouldn't include x equals to 2 here, right? So I only want to minus 0 and 1. Okay, this is the general formula that we have here, and try to press calculator, and this is the answer that you should get correct to 3 significant figures. Okay, so this is how we answer question number. Right, so question number 2. The length of a certain species of lizard are known to be normally distributed. I think you can highlight the keyword normally distributed with a standard deviation of 3.2 cm. So the 3.2 is the population standard deviation. And we are having a random sample of 100 lizards. And I'm using this random sample, right, to get the alpha percent confidence interval for the population mean. Okay, so highlight the keyword confidence interval and for population mean. He finds that the total width of the interval is this value and find the alpha. Right, so let's have a look for setting up the question first. Yeah, how can we set up the question? The keyword actually is at this part, the confidence interval for population mean. So we are having two types of confidence interval, right? We are having population mean confidence interval and also the confidence interval for population proportion. So this one is for the mean one. Therefore, I only focus on the mean formula. What's the general formula for the confidence interval for population mean? So the general formula is sample mean minus z multiplied with alpha over square root, sigma over square root n. Then the upper limit will be x plus z sigma over square root n. So we are having the general formula for the confidence interval for population mean. And from here, right, we are having the lower limit and also the upper limit. This is the lower limit and this is upper limit. When they are talking about the width, what is the meaning for the width? That means how how big, what is the value between the lower and upper limit. Therefore, to get the width, you need to take upper limit minus the lower limit. Because I want to know the distance between the lower and upper limit, right? Which is the width. So I have to take the upper limit minus the lower limit. So if you minus upper limit by lower limit using you use upper limit minus lower limit, then by right you should be getting the width formula as 2z, then sigma over square root n. So this is just in case if you can't remember the formula, then you can just use the original formula and get the formula for the width. All right, and in this question, they are giving us with the width. So by using this information, I want to set up the question, and maybe it can help us to continue and find out the alpha. All right, yeah. So let's have a look for the width first. Okay, so I'm having the width equals to 1.25. Then since I know that the general formula for the width is 2z, then sigma over square root n equals to 1.25. Then let's have a look what are the values that we can substitute in here. So sigma is the population standard deviation. It is given here, which is 3.2. Then what is the sample size? N. So the sample size N is 100 and it is equals to 1.25. Okay, then if you continue from here, right, to solve this particular equation, you will be getting the Z value, which is 1.953125. And then I will correct it to 3 decimal place. correct to 3 decimal places here, because of in our normal distribution table, all the value of Z is up to 3 decimal places accuracy. Alright, so I keep it as 3 decimal places here first. So I get the value for the Z. Alright, so if I'm having this value of the Z, how can I use it to find out the percentage for the confidence interval, the confidence level for the confidence interval? So I will try to link it by using a very common, a very general graph, I would say. Okay, when we are calculating the confidence interval, right? Okay, the alpha percent means the center percentage for the confidence interval. Okay, and this confidence interval is from normal distribution, right? Therefore, I know that my center percentage here is alpha percent. This is the confidence level that I have for any confidence interval in a normal distribution question. Okay, this whole thing is the alpha. I want to know this alpha for now, but so far I only have a value of Z, okay, from the information given. So I know that this particular value of Z is 1.953, and this particular value of Z will be negative 1.953 because it is a symmetrical graph. Okay, all right. So if you are having this value of the Z 1.953, how can you try to figure out the value of the alpha here? And if you successfully try to draw out this normal graph, right, with a center percentage of alpha, it will be quite easy for you to calculate the alpha. But there are many ways. Okay, there are many ways. So for me, I will try to figure out this area first. Okay, so I try to figure out this particular area first. Okay, so what I do here is I try to put it as this. I want to calculate the probability of Z greater than 1.953. Okay, so how can I get the area for Z greater than 1.953? So I need to take 1 minus then the answer that I get from the table, 1.953. Okay, so let's have a look here. 1.95 is this value, then 3 you have to add 2. So 1.953 will give you this one, 9744 plus 2 at the last digit. You'll be getting 9746. Okay, yeah, so we go back to our calculation here. I'll be having 0.9746 and I have 0.0253, which means that this particular area here is 2.53%. If you want it to be more accurate, if this is 2.53%, then this white color area on the left is also 2.53%, right? Because they are symmetrical. Okay, so it also means that this is 2.53%, and we know that the total area under the graph should be 1, or we calling it as 100%. And I think it is quite obvious already, because from here, since you already know these two area or these two percentage by the side, it should be no problem for you to get the alpha. All right, so let's continue to get the alpha. To get the alpha percentage, it means that I have to take 1 minus 2 times of 0.0253 and I multiply it with 100%. So from here, you should be getting 94.94%. And as the final answer, I want to keep it up to 3 significant figure only. So I will put it as 94.9%. Okay, so this is correct to 3 significant figure. All right, so by using the value of Z, then I will know how to get the alpha. All right, so I did check the marking scheme for this particular set of paper. Marking scheme did allow or accept 95% is accepted. Okay, but for me, usually I will just keep it up to 3 significant figure. Right, so I will just keep it as 94.9. Right, this is how we answer question number. Question number 3. In the past, the mean time taken by Frida for a particular daily journey was this value, 39.2 minutes. Following the introduction of a one-way system, she wished to test whether the mean time for the journey has decreased. Highlight the keyword decrease. Okay, she notes the time, t minutes for 40. Highlight the keyword 40. Randomly chosen journey and summarize the result as follows. So all these value here are summarized from 40 journeys, which is actually meaning the sample. You are having the sample size 40, and all these are the numbers summarized from this 40 sample. Okay, so calculate unbiased estimates of the population mean and also the variance. Right, so highlight the keyword unbiased estimates for the mean. Okay, so what's the general formula for the estimated mean? So the estimated mean value will be summation of x divided by n. And the estimated value for variance, or according to our table, right, they are putting it as s squared, also can. There are a few formula here. One of them is 1 over n minus 1. Then summation of x squared minus summation of x squared, the whole thing, divided by the n. This is the formula for unbiased estimates of mean and also the variance for population. Okay, so just in case you can't remember this formula, basically they are provided in the formula booklet. So you can go to MF19. Then under the probability and statistics part, you scroll down and then you will see this one. Under the sampling and testing part, this is the unbiased estimated value for the mean, and this is the unbiased estimated formula for variance. So there are two. One is this one, another one is this. For me personally, I feel that this formula is more convenient to be used. This one is quite tedious because you need to find the population. You have to use the sample mean, get the value one by one. To me, I think some question is not suitable. So for me, usually more straightforward one, I will use the second one. Okay, right. Yeah, so this is the formula that we have. So for this question, it is particularly quite straightforward, I would say. So to calculate the mean, I just take summation of t in this case divided by n. So what do I get here? I will get 37.6. Then how to get the variance? So to get the variance, it should be 1 over n, which is, 1 over n minus 1, which is 39. 40 minus 1 is 39, right? Then summation of x squared, 57760, minus the 1504 square divided by n, 40. Then you just need to try and press calculator to help you to get the answer. I'm having 2016 over 15. Over 65, not 15. Over 65. Then for those who prefer the decimal number one, you can make it become 31.0, correct to 3 significant figure. For me, I would strongly suggest you to keep your variance in the fraction form first, in this case, because I believe that in the later part, because this is just part A, right? I believe that in the later part, you might need to use this to do some other calculation. So for me, I will keep it as a fraction form. So this is what we have for part A in question number 3. And let's continue further to part B. So they want you to test at 5% significance level whether the population mean time has decreased. Highlight the keyword decrease. When you want to run a test, right, this will be a keyword to help us and set up the alternative hypothesis. Okay, so let's go back to our part A here and read the question one more time. All right, so they are talking about the time for a particular daily journey. Okay, we are having a large sample, 40, and when we want to carry out the test, we are trying to test the population mean, because we actually don't know the population mean here, right? We want to test whether the population mean is different from this one or not. Okay, therefore, when we are having a large sample and we are trying to test on population mean, we need to use a normal distribution and also the sample mean. All right, okay, so let's start with the very first step. What is our null hypothesis and also the alternative hypothesis? We are going to test on the population mean. So originally it is 39.2 minutes. And they want to test whether the time has decreased. So you can see that I highlight the keyword here, right? Decrease means that the mean will be less than. So you put a smaller sign than 39.2 minutes. So this is the very first step every time when you want to carry out the hypothesis test. Okay, that done. All right, so this is the first step. Second step, because we know that the sample size is large and we are testing the population mean, therefore we will want to use the normal distribution to carry out the test. So when we are using the normal distribution, first of all, we want to know what is our critical value. All right, so how I know that what is my critical value and how to set up the critical value part. Okay, we are given 5% significance level, right? So that means my rejection region or the area will be 5% or 0.05. And because of this is a one-tail test on the left, from here, alternative hypothesis is smaller. So it is one-tail test on the left. That means my rejection region will be on the left-hand side. And it has the meaning that this is the area of 0.05 coming from the 5%. And I wish to know what is this particular value here, and this value we will call it as the critical value. Okay, so how to find the critical value? I need to find out the Z, this in the normal distribution table in the reverse way. Okay, so if I'm having a small area here is 0.05, then this white color area, which is a large one, should be 0.95 because they are complementary of each other and total of them should be equals to 1. Then I go back to our table here, how to get the value of the Z from a table. So usually I will tell students, if can, you try to have a look for the shortcut table first, because the shortcut table might give you all the some important area. So like for this one, our area is 0.95. Okay, then the value of Z is 1.645. All right, you cannot use the 0.05 because from our table, all the area are more than 0.5. So I have to use a complementary area to find out the Z. So I'm using 0.95 here, and the Z will be 1.645. Then when I want to label my critical value, since my rejection area is on the left, so this particular part, all the value of the Z should be negative value. So I just directly put negative 1.645. So this tells you the critical value actually separate the rejection region and also the acceptance region when you are trying to carry out the test. Right, so this is the second step. Then third step, we are going to get the test statistic. Okay, so how to get the test statistic? You have to calculate by yourself. Our test statistic in a hypothesis test for population mean is this one. Sample mean minus the population mean divided by standard deviation over square root n. Okay, so now I just plug in all the possible value that I have into the calculation. So what is the sample mean just now? It is from the first part. The value of the sample mean is 37.6. We did learn, right? The formula for sample mean and also the population mean, my estimator for the population mean is the same. So you have to use the sample mean from previous part also, which is 37.6 is the same value, minus the population mean in this case that we want to test is 39.2 divided by sigma. So what is a sigma? So you have to use back our previous question also. The sigma means standard deviation of a population. From here, I actually get the estimated population variance, right? So I should apply this value into my calculation here. So, but I need only the standard deviation. So what I do is that I take the square root of this value, 0.016 over 65, then divided by square root n. So divide by the sample size 40. Okay, yeah. I think I shouldn't squeeze it. Wait, let me write it properly. Okay, so I'm having 37.6 minus 39.2 divided by the square root of standard deviation or variance, population variance over n. N is 40. Okay, so try to calculate out the value. I make it correct to 3 decimal places again. So it is negative 1.817 for the Z. Alright, so this is the third step when you carry out the test. First step, write out the null and alternative hypothesis. Second step, try to find out the critical value. After that, find out the test statistic. Next step is we need to do a comparison to know whether should I accept or reject the null hypothesis. So let's have a look for this Z here, negative 1.817. If I want to place it into the diagram that I draw just now, where should I put it? So I should put it under this part because this value is smaller than the critical value. And from here, I want to write out a comparison statement where I'm having test statistic negative 1.817 is less than the critical value, which is negative 1.645, right? So this is a comparison statement that you must write it out because it helps you to draw a conclusion. So after this comparison statement, please write out the conclusion for this test. So as a conclusion here, the negative 1.817, this particular line falls under the rejection region. Therefore, we have to reject the null hypothesis. So reject the null hypothesis, it means what? It means that there's sufficient evidence to show that the mean has decreased. Okay, yeah. So basically, this is the important steps that you need to show when you want to carry out a test. There are 5 main parts. For me, I separate into 5 main parts here. Null and alternative hypothesis, then the critical value, test statistic, comparison statement, and also the conclusion. All right, so this is how we solve question number. Okay, we are now at question number 4. The number of accidents on a certain road has a Poisson distribution. So highlight the keyword Poisson. This keyword is very obvious, yeah? With the mean 0.4 per 50-day period. They want us to calculate the probability that there will be fewer than 3 accidents during a year, which is having 365 days. Okay, for any Poisson distribution question, we need to calculate the probability, right? So the general formula for it will be this one. So we need to have the lambda for Poisson distribution. And after that, to calculate the probability, general formula will be x equals to r, can be written as e negative lambda, lambda power r divided by r factorial. So this is the general formula here. Okay, then now when you want to set out this question, right, they give us the mean or the lambda for 50-day period. It is 0.4 for 50 days, but now we are having the calculation for 365 days. Therefore, you need to adjust the lambda at first before you start the calculation. Okay, so let's start, yeah. I know that the 0.4 is for 50 days, right? So I make it divided by 50 so that I know for 1 day what is the lambda. After that, I have to multiply with 365 to get the lambda for 365 days. Okay, so if you didn't do any careless mistake, by right, you're having 2.92 here. And they want you to calculate the probability for x smaller than 3. Fewer than 3 accidents. Fewer, so not include the 3. So when we are having x smaller than 3, that means what? That means we have to get the probability for x equals to 0, x equals to 1, and also x equals to 2. When x is equals to 0, I'm having e negative lambda. Then lambda power 0 divided by 0 factorial will give you a 1. When you are having x equals to 1, I also have e negative lambda, but I just factorize it outside already. Then here I want to have lambda power 1 divided by 1 factorial. It will be the lambda itself. Okay, then when x equals to 2, I take the e power negative lambda, factorize out. Then I'm having lambda power 2 divided by 2 factorial. So according to the formula here, smaller than 3 shouldn't include the 3. And therefore, I stop at 2. Right? Then just press calculator and see what you get. So by right, you'll be getting this long answer here. Then I want to correct it to 3 significant figures. So by right, you should be having 0.441 correct to 3 significant figure. Okay, All right, so this is what we have for part A. And let's continue to part number B. So now they tell us that the probability that there will be no accident during a period of n days is greater than 0.95. So find the largest possible value of n. Okay, so for the calculation of the probability here, right, they are referring to n days now. So let us set up the lambda first. So x is still Poisson distributed. For 1 day, the lambda is 0.4 divided by 50 for 1 day. And now I'm having n days, so I have to multiply it with n. Like just now you multiply 365, right, for 1 year. So now I'm having n days, so I multiply with the n. And if I try to simplify, I will be getting 0.008 n. Okay, this is my lambda. And how can I find the value of the n here? As requested in the question, we have to use the information given in the question to start with. So for here, for this part, they are giving us one useful information. No accident. Probability of no having accident is greater than 0.95. How can I convert this particular sentence into the symbol? So probability means P. No accident means X equals to 0. No accident, number of accident equals to 0. The probability is greater than 0.95, so more than 0.95. Okay, so just put in the formula for x equals to 0. I'm having e negative lambda, then lambda power 0 divided by 0 factorial is greater than 0.95. So we are having e negative 0.008n greater than 0.95 because anything power 0 is a 1, 0 factorial is also a 1. Okay, then when you want to solve this inequality, to take out or take down the power as a number, you need to take ln both sides. For me, I prefer to take ln in this case. Okay, because this is a value of the 1. Ln e, you will get a 1. Okay, and after that, to get the value of the n, you need to move the negative over. So when you want to move the negative over, it will be negative 0.008. Press calculator and help you a bit on the calculation here. And you should be getting 6.411661798. Okay, they are talking about the number of days, right? It should be whole number. All right, so what is the integer that is smaller than 6.4? So the whole number should be equals to 6. So the value of n should be equals to 6. It shouldn't be smaller than 6 or smaller than whatsoever, yeah? It should be equals to 6 because they are asking largest possible value of n. So the largest integer below the 6.4 will be the 6. All right? Yeah, so this is how you answer question number 4. Okay, we are now at question number 5. The bottle of Lanta contains approximately 300 milliliter of juice. Then the volume of juice in milliliter in a bottle is 300 plus x, where the x is a random variable with the probability density function as shown here. Okay, right, so they want us to find the probability that a randomly chosen bottle of Lanta contains more than 305 milliliter of juice. Okay, what does it mean for this particular question? So you need to know that for the bottles, right, it is having approximately 300 milliliter. And then the difference for every single bottle is actually 300 plus x because the x can be from negative 10 to positive 10. So if let's say x is negative 10, that means the bottle might have 290 milliliter of juice. Then if let's say x is equals to 10, then the bottle might have 310 of the juice in the bottle. So that means the range of the bottle contained is between 290 to 310. All right, but only the x, okay, is in the probability density function. So here you should know that the minimum value for the x is 10, negative 10, and the highest value for the x should be the positive 10. Okay, right, so when they are talking about find the probability that a randomly chosen bottle of Lanta contains more than 305 milliliter of juice, what does it mean? It means that your x must be more than 5, right? So that 300 plus 5, then only you'll get more than 305 milliliter. Alright, so that's how you interpret the question. So you need to understand the question first. Okay, so first of all, to calculate the probability, of course, we need to include the integration. You have to apply integration here. And to calculate the probability, what's the general formula to get the probability here? X greater than 5, that means the lower limit for this particular question should be a 5. And then the maximum value for this x should be 10. Can you see that here? This is a 10. And I want to integrate the probability density function. So 3 over 4,000, then 100 and minus x squared. Okay, so this is what so far we have. So we have to integrate this to get the probability of x greater than 5. Because when x is greater than 5, then only I will have the bottle contain more than 305 milliliter of the juice. Alright, so let us start the integration. So for the integration here, personally my habit is I prefer to take out all the constant first. So 3 over 4,000. Then integrate the term 100. Integrate 100, you'll get 100x. Integrate negative x squared, you'll be having x power 3 divided by 3 factorial. Then put in the value of 10 and also the 5. Okay, so next step is you try to substitute in the value of x and also the 5 into your into the terms after your integration. Substitute 10 first. 10 substitute here, you'll be having 1,000. Then minus 1,000 over 3. After that, you have to minus substitution of the 5. So 5 substitute into the first term, you're having 500. Then minus 125 over 3. Okay, then after the substitution, try to use calculator to help you. Final answer that I get here is 5 over 32. Or we can make it as 3 significant figure, which is 156. Okay, so this is what we have for the part A. Right, then let's continue to part B. Now, given that 25% of bottles of Lanta contain more than 300 plus p milliliter of juice, show that you are getting this equation after this, after you try to figure it out, right? Okay, so here they already give us the information where the probability is 0.25, sorry. The probability is 0.25 or equivalent to 25%. Then contain more than this amount of juice, it means that I'm interested to get the probability of x greater than p, and this probability should be equals to 0.25. Okay, then again, how to get the probability here? You have to integrate. So I'm having p, lower limit, the upper limit is a 10 because the maximum x can go up to 10 only. And again, try to integrate the particular function, the PDF. Then 100 minus x squared. And it is equals to 0.25. So for the rest of the steps, you just carry on as usual. You try to integrate them, then you substitute in the limit. Yeah. So integration, integrate of 100, you get 100x. Integrate of x squared, you are having x power 3, power plus 1 divided by the new power. Then substitute in the limit 10 and also the p. And this probability is given equals to 0.25. Then next step, what should we do? Substitute in the value, right? So 100 times 10, you're having 1,000. Then 1,000 over 3 minus 100p minus p power 3 over 3. And after that, for now onwards, you can try to move and simplify all the fractions slowly. Okay, so for the next step, what am I doing here is I try to bring this fraction go to the other side. So when I bring it to the other side, I'll be having 1,000 over 3. 1,000 over 3. Okay, then for all the terms inside this square bracket, everything here, after I simplify, I'll be getting 2,000 over 3 Okay, then minus 100p, then plus p power 3 over 3. Okay, then multiply the whole equation by using the 3. Okay, then further simplify it. Yeah, so this is what you get for the equation that they want you to prove. Okay, all right. So this is what we have for part number B. Then let's continue to part C. Okay, for part C, given that P is equals to 3.47, and also they give another extra information where 50% of the bottle, right, contain between 300 minus Q and also 300 plus Q milliliters of juice, then they want you to find the Q and justify your answer. All right, so first of all, maybe I want to focus on this information given in the question first. So they said the 30 minus Q and 30 plus Q, right, the percentage is 50%. And if I try to draw a diagram, because I think it's easier for us to visualize from the diagram here for the x. Okay, so like what I told you just now, the x can take the smallest value of negative 10 and the highest value of positive 10, right? Okay, so I try to label them out first. This is negative 10 and this is positive 10. And then if you have a look for the function of the x, it is this one, 3 over 4,000, then 100 minus x squared. So what is the x squared? How is the x squared graph look like? The x squared graph is a U shape. It's a quadratic curve, right? It's a U shape. But when you have negative in front of the x squared, it will become N shape. So it will become N shape. All right. Then after that, when you try to move it up to plus 100, that means you move up 100 unit. And therefore, your graph will be something like this. Move up 100 and you multiply it with 3 over 4,000. So 100 multiplied with 3 over 4,000, you're having 3 over 40. So I'm trying to visualize it, the question here by using the function, the diagram of this function. If I try to sketch it out, it will basically look something like this. So by right, you know that it is an N-shaped curve. It is actually a quadratic curve, right? N-shape. So my one doesn't draw it very nicely. So for you yourself, please draw it nicer. Okay, and you need to know that this particular diagram is symmetrical at the line x equals to 0. Okay, cannot be symmetry. Wait, you assume that this is symmetrical. Okay, then now I want to plug in my value of here. So they said from negative Q to positive Q, it contains 50% of the probability. Okay, so let's say I am having a negative Q here. This one I'm having a positive Q. Then the particular area from negative Q to positive Q, it is actually 50%. This one is 50%. Okay, so like what I told you just now, right? When we are having the diagram here, this diagram should be symmetrical at the line x equals to 0. If this is 50% from negative Q to positive Q, what is this particular area? It must be symmetrical. So the remaining are 50% in total, and you divided it into two parts because they are symmetrical. So this particular area is 25%. This is also 25%. So what do you aware just now? So just now in part number 2, right? We know that 30 plus P, more than 30 plus P is 25%. Okay, so if I go back here, just now from part number 2, we are having the probability of x greater than P is equals to 0.25. Yeah, so from here you actually can see that Q and P should be the same thing, because when I look at this diagram, the probability of X greater than Q is also 25%. Correct? Yeah. Okay, so you can make a conclusion from the diagram here lah. So, but before that, we need to point out a few important note here. Okay, so what should we do is like, okay, this one I will put it later. So first of all, what I want to emphasize here is, according to the diagram, we know that the probability from negative Q to the positive Q is equals to 0.25, 0.50. Okay, and since the function is symmetrical, because it is symmetrical at x equals to 0, from this fact, you know that I can also write out the probability of x greater equals to q is equals to 0.25. Then at the same time also, we get x greater than p, okay, is also equals to 0.25 from part number 2. And it is given that p equals to what? P equals to 3.47. So from all this fact here that we write out, we know that Q is equals to P, and Q should be equals to 3.47. For me personally, I feel that if you can draw out the diagram, then it will be easier for you to visualize the whole picture. Okay, all right. So this is how you get the answer for the Q, and this is how we answer question number 5. Okay, question number 6. Right, so we are having the volume in milliliter for large and also small cup of tea are modeled by the distribution of normal. So both of them are having normal distribution, yeah. For me, I'm labeling the large cup as L, then the small cup as S. Right, so first question, find the probability that the total volume, highlight the keyword total, of randomly chosen large cup of tea and a randomly chosen large cup of small cup of tea is less than 300. Excuse me, a large cup and also a small cup, and it is total. So when I want to write out this particular symbol here, right, total of one large cup and also one small cup, it should be written out like this. Is L plus S, right? 1L plus 1S. Okay, then before we calculate the probability, we need to know what is the mean for L and also the S. L plus S. So I need to have mean of L plus the mean of S, mean of large plus the mean of small. So you're having 200 plus 110 equals to 310. This is the mean. And how about for the variance? So for variance, I want to have variance L plus S, which is variance L plus variance S. And the variance for the L is 30, then variance of S is 20, and the total should be 50. Okay, since both L and also the S are normally distributed, therefore the linear combination L plus S is they are linearly adding together, right? So it is also normally distributed with the mean of 310, variance is 50. And for this question, we are interested to calculate the probability of total L plus S is less than 300. So less than 300. So this is what you want to calculate here. Okay, then to calculate the probability, since we know that L plus S is normally distributed, therefore to calculate the probability, I have to change it become Z. So how to change it become Z? You have to take the value minus the mean. So what's the mean for both? 310, right? Divided by standard deviation. So what's the standard deviation here? It should be square root 50. And what do you get for the value of Z in this case? So you're having Z is smaller than negative 1.414. Then please try to figure out the probability from the table. You have to take 1 minus, looking for the value of 1.414. Okay, so 1.41 is this one. Then 4 is here. So you are taking 9 207 plus 6. Then you're having 9213. Okay, right, I have to take 1 minus 0.9213. And from here, the answer that you get should be 0.0787, already correct to 3 significant figure. Alright, then let's continue to part B. Okay, for part B, they want us to find the probability that volume of a randomly chosen large cup of tea is more than twice the volume of a randomly chosen small cup of tea. I want you to highlight the keyword twice. For this particular phrase here, how can I write out the correct symbol? One large cup of tea means L. More than means greater than. Twice the volume of a small cup of tea. Twice means times 2 for a S, a small cup. So L greater than 2S. And this is the probability that you want to calculate it for this question. Okay, then I cannot calculate the probability if let's say having two random variable at both sides. So what I want to do is that I have to move all the random variable to one side. It will become L minus 2S greater than 0. Of course, you want to move it to the other way. 2S minus L smaller than 0 also can, up to you, alright? And because of, I want to change it become this one later. Therefore, before the calculation, I need to calculate the mean of L minus 2S first. So it will be the mean of L minus 2 times of mean of S. Okay, so mean of L is what? It is actually 200 minus 2 times of 110. So you are getting this negative 20 here. Then how about for variance? So for variance L minus 2S, I will be having variance of L. Then plus, there's a plus here. For variance, it is always positive. Therefore, all the minus will become a plus. Okay, then it is the multiple of the small cup of tea. Multiple means twice here. The twice here means 2 times. It is a multiple. To calculate the variance, you have to square the constant 2. Right, so 2 square with the variance of the S. So what do we have from here? You're having 30 plus 2 square multiply with 20. And you are getting 110 for the variance. So the general, so we have to write out the distribution of L minus 2S. Yeah? It is still a linear combination of 2 random variables of normal. So they are still normal. Okay, then the mean is negative 20 for this case. And also the variance will be 110. Okay, then I want to calculate the probability of L greater than 2S. Like what I showed you just now, I have to move it become L minus 2S greater than 0. Since L minus 2S greater than 0, the L minus 2S is still normally distributed. To calculate the probability, I have to change become the Z. Right? So how to change it become the Z? You have to take the value of X minus the mean. So minus mean is negative 20 divided by the standard deviation, which is the square root of 110. Okay, so what's the value of Z that we get here? I'm getting 1.907. Then again, you have to use a normal table to help me and figure out the probability. Okay, so 1 minus, I'm looking for 1.907. Okay, so 1.90. 1.90 is this one. Then 7 is 4. So you're having 9713 plus 4 here. Then this is what you get, 9717. Okay, so you have to take 1 minus 0.9717. Then by right, you'll be getting the answer 0.0283. Also already correct to 3 significant figure. Alright, so this is how we solve the question number 6. Okay, so we are now at the last question for this paper, question number 7. There's a national survey shows that 95% of the year 12 students using the social media. So Arvind suspect that the percentage of year 12 students at his college who use the social media is less than. I need you to highlight the keyword less than. okay, less than the national percentage. He chose a random sample of 20 students at his college and note the number who use the social media. He then carried out a test at the 2% significance level. So find the rejection region for the test. Right. So this question is about the hypothesis test. And what are we testing for this particular question here? So you can see that we are testing the percentage, or we are trying to test the proportion, which is the P, okay, for the number of students who use the social media, year 12, right? So this is basically a P. So 95% means that P is equals to 0.95, and we want to test on this particular value because we suspect that the percentage or the proportion should be less than the national percentage. So less than give you an idea to set up the alternative hypothesis, okay, where your P should be smaller than 0.95, right? Yeah, so basically this is the hypothesis test question. Then to make everything clearer, maybe you can try to set up the null and alternative hypothesis first. So this is a hypothesis test for population proportion. And we are having P equals to 0.95. And after that, P smaller than 0.95. Okay, when we want to carry out any test, right? If we want to test about the population mean, we are using the sampling distribution. Okay, so you can refer back to question number 3. So you can have a look here for question number 3. I think it's this part, right? Yeah, we did discuss it just now. For question number 3, when you want to test the population mean, you can see that the test statistic we are using X bar. X bar is the sample mean. That means we are using sampling distribution to carry out the test if we want to test the population mean. Okay, then for this question, we are going to test on the population proportion. To test on the population proportion, the distribution that we are using is a binomial distribution, where X is binomial distributed. In the question, they will tell you what is the sample that they are using. So it is taking a random sample of 20 students. So the 20 here basically is the N, the total number of trial that you have, right? So we are having 20 students. And what are we going to test is, we are going to test the population proportion, which is equals to 0.95. Right, so this is basically how we start this question. And since they want us to find out the rejection region for the test, right? So let us carry out the calculation, how to find the rejection region. Okay, so before we continue, I just want to show you again for question number 3 just now. For question number 3, when you want to carry out a test, right, I will draw a normal diagram. And then you can see that I try to shade the rejection region. So this rejection region is on the left-hand side because it is a one-tier test on the left, correct? So that's the reason why do I have this, right, the shaded area. So the shaded area means the rejection region, and it should be on the left. And then the area of the shaded region is 5% significance level, so which is the 0.05. So this is applicable for the normal distribution. And now when we come back to this binomial distribution, by right, we should be also having the rejection region. So just now in question number 3, right, because it is normally distributed, therefore you can see that I'm trying to draw the bell-shaped curve. But for binomial distribution, it is not look like bell-shaped curve. So what am I going to do now is, usually for me personally, I will try to draw a bar. But of course, this is not the correct bar that you can draw it out in the exam. All right, but it is mainly for the understanding purpose, and also mainly for some students who need some graph or diagram to visualize it. All right, okay, so for the X, I'm having 0 until 20 because the largest students number that I can take is 20. So from 0 until 20. And then where should be my rejection region? So my rejection region should be on the left because it is one-tier test on the left. Aware of it? So smaller than. Therefore, I will have a particular area and I shade it, referring this as the rejection region, the rejection area, okay? All right, then this, how big is this area? The area here is having the probability of 0.02. Which is a very, very small area because here they write it as 2%, right? So it should be 0.02. Okay, so I'm having x equals to 0 until x equals to 20. Alright, when I want to find out the rejection region, I need to test the value one by one so that I want to see if, let's say I'm having the x equals to 1 here. When I want to know whether my x equals to 1 falls under this particular area or falls under this particular area. So to find out the 1, whether is it under the rejection region or in the acceptance region, I need to figure out the probability or the area, because this is the probability or the area that I shade and it is belongs to the rejection region, right? Yeah, so at the beginning part, I need to test the value one by one. So what I will do is that I will test x smaller equals to 1. Okay, so x smaller equals to 1. Using binomial distribution, it will be 20C0, start from 0, 0 0.95 power 0, 0 0.05 power 20. Then plus 20C1, 0 0.95 power 1, 0 0.05 power 19. Okay, looking at these two formula here in the binomial distribution, basically we can we should expect that the value that I get here should be a super small value, because I'm having 0 0.05, which is a very small value, power 20. So by right, you should be getting a super small value, right? Then it's okay. You try to use calculator and help you to figure out what is the value for this one. So if you didn't do any careless mistake, by right, you're having 3.6 multiplied with 10 power negative 24, which is a super small value here, right? So this is the probability for x smaller equals to -1. That means if I compare it with this 0.02, 3.6 multiplied with 10 power negative 24 is super small. It's an area that is super small compared with 0.02 that I shaded here like this. So you can expect that maybe when I want to draw a line for the 1, so this is the area for x smaller equals to 1, where it is equals to 3.6. The red color one is 3.6, then 10 power negative 24. Okay, and it also shows you that the 1 here actually falls under this rejection region. The shaded area is the rejection region. So the 1 falls under the rejection region. So by trial and error, you need to test and find out what is the value of the x so that it falls under the acceptance region. Okay, so you need to figure out by trial and error. Okay, so for the next one, some students might want to test on x smaller equals to 2. But because of negative 24, 10 power negative 24 is a very small value. So that means what? That means what you need to do here is you can actually skip a few numbers so that you can find out the bigger probability. So as an example, maybe some students say that I want to skip a few numbers. I've tried to find out x smaller equals to 6, let's say. So to find out x smaller equals to 6, then you will need to have 20C0 plus 20C1 blah 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 plus 20C2 plus 20C3 plus 20C4 until 20C6, where the calculation can be very long. So some students, with if let's say you are very patient, then you can just try to figure out the probability one by one. Okay, but for me, I feel that it is really troublesome or very hard for me to calculate one by one, because this value is way too small compared with the 0.02. So there's a easier way for us to get the probability for all the values here. What we can do is that by using the summation term in the summation function in our formula, in our calculator. Okay, all right, because you can see that when I want to calculate all the probability here, right, it is 20C0, then 0 0.95 power 0, 0 0.05 power 20, and plus the next one is 20C1, and all this number will increase one by one. So what am I going to do is I want to key in a general formula by using the summation. So the summation is I want to start from x equals to 0 until the number that you want to find out. Okay, then in general, it is actually 20C something, 20cx, 0.95 power x, 0.05 power 20 minus the x. So that means if you key in this formula, this particular formula in your calculation, okay, key in this formula in your calculation, in your calculator, sorry, then you can get the summation of all these very easily. Okay, all right, so as an example, let's say we take the x smaller equals to 1 as example first. All right, so now you already press the calculator for the value, right? Yeah, so I need to key in the formula so you can see it from here. You can press shift, then the log function. It depends on what kind of formula calculator are you using. I think most of the calculator can be used as long as it is the 570 ES or either MS. Okay. Alright, so I want to key in the formula inside first. So you can see from here 20cx 0.95 power x 0.05 power 20 minus x. So I just key in first 20cx is this one. Okay, then after that, what do I have? I have to multiply 0.95 power x. So power x. Okay, sorry, x is this one. Okay, then after that, what else do I need to do? I also need to multiply 0.95, 0.05 power 20 minus x, right? So 20 minus the x. And this is what I have. And when I want to sum them up together, right, I have to start from the value of x equals to 0. So here, the lower limit, I will put it as a 0. Then because we just want to try out for the answer x smaller equals to 1, right? Okay, then now the upper limit here, you put it as a 1. So this one actually means that you want to substitute x equals to 0 into the equation, then plus substitute x equals to 1 into the equation and get the answer. So let's press equate and see what do we get. So you get 3.63 multiply with 10 power negative 24, which is correct as what we calculate just now. Okay, so we can save a lot of time by using this function in the calculator. Okay, all right, then let's continue further. So like what I told you just now, since I know that x smaller equals to 1 is having a super small area compared with 0.02. So to try and error, right, to test the value try and error, you can try to use a bigger number of the x. So maybe now I want to put it as x smaller equals to 11. And what is the probability that will I get? So you can have two options now. Either you press the formula one by one using your calculator. It might take a longer time. If not, then you can just use the function in this calculator and get the answer. So what am I going to do now is all the formula here will not be changed, remain the same, but I'm changing the upper limit here from 1 become 11. Because the largest number for the x I want to include here is 11. Then please press the equal sign. And the probability that I get is 1.98 multiplied with 10 power negative 7. So I will take 1.98 multiplied with 10 power negative 7. Oh, then I forget to compare. This one is less than 0.02. This one is still less than 0.02. And 10 power negative 7 is still quite far away from 0.02, right? Okay, so this question, this value also tells us that the 11 still falls under the rejection region because the whole area on the left hand side of 11 is 1.98 multiplied with 10 power negative 7, which is still smaller than 0.02. That means you haven't get the largest possible value under the rejection region yet. So let us continue further. Okay, 11, it is still smaller than 0.02, but it is getting slightly closer to the 0.02 already compared with the power negative 24, right? Okay, then maybe now I don't want to skip so many numbers anymore because I scared that I will miss out some values. Maybe now I try to have x smaller equals to 15. And I want to see what's the probability that I get. Okay, then again, to get the value, either you press the calculator one by one, or you can take 20 minus 16, 17, 18, 19, 20 also can. It depends on how you interpret it, all right? So for me, I'm using this, and then I try to press 15. change the upper limit become 15 and press the equal sign, and I get 2.57 multiplied with 10 power negative 3. So 2.57 multiplied with 10 power negative 3. It is still smaller than 0.02. So that means if I try to draw the line 15 in the diagram, it is still under the rejection region because the whole area below 15, okay, it is equals to 2.57 multiplied with 10 power negative 3, which is still smaller than 0.02. But if I try to investigate further, I will know that this power 10 power negative 3, right, is not too far away from 0.02 anymore. So when you are very close to the alpha that we have, or the significance level that we have, then you shouldn't skip too many numbers anymore. You should try one by one. So the next value I want to get is x smaller equals to 16. Okay, so again, come back to the calculator, change the upper limit becomes 16 then. Okay, so this one I want to change it become 16. Then press the equal sign. And then you're having 0.0159. Okay, then 0.0159. Compare with the 0.02, it is still smaller than 0.02, which means that 16, it is still under the rejection region 16. Okay, because the area that we get is still smaller than 0.02, right? Yeah, so we are very, very close. Maybe I think the next number can show that it is under the acceptance region already. Never mind, let's try. So x smaller equals to 17. Again, go back to the calculator. Alright, then after that, change the limit. Okay, let me change the limit first, yeah? Oh, okay. Okay, let me go to 17. Okay, so I want to try to find out the probability from 0 until 17. Press the equal sign, and you get 0.0755. And what do you get? If you compare it with 0.02, it is already more than 0.02. That means if you calculate the area for this x smaller equals to 17, or the probability, you get an area that's greater than 0.02, which also means that if you want to draw a diagram here, the 17 should fall under acceptance region already, because the area below the 17 should be greater than 0.02. So it should be outside the black color area. Correct? So from here also you can see the 17 basically falls under the acceptance region in the white color part. So what does it mean here? From here you can see that the x from for x from 0 until 16 are all under the rejection region, and then from 17 until 20, all of them falls under acceptance region. Okay, so from this diagram, you can state out clearly that your rejection region is what? Rejection region is basically x smaller equals to 16. The 16 itself is included in the rejection region, or you can write out in this way where x smaller than 17. 17 does not include it, including in the rejection region. You are having 0 until 16. So either one of the way that you writing can be accepted in this question. Okay, yeah, so I'm using this diagram to help and explain so that you visualize or you try to understand better what am I trying to show. Okay, but there's one thing I want to emphasize here. This particular diagram cannot be shown in the exam or cannot be shown in the solution, because this is not a valid diagram. It is mainly for understanding purpose. Alright, so after you draw it, maybe you should try to erase it. Okay, because the binomial graph basically doesn't look something like this, but for understanding purpose, I try to make it in this way so that you can see it clearly. Okay, so where should you accept and where should you reject? Therefore, for this question, the rejection region will be x smaller equals to 16. Okay, all right. Then let's continue further to next part. So for next part, they want you to calculate the probability of a type 1 error. Okay, what's the definition for the type 1 error? Basically, you need to memorize it, okay, because it will be very helpful for you to calculate it. Type 1 error is reject the null hypothesis when the null hypothesis is true. In calculation part, reject the null hypothesis means that you have to put in the rejection region. So what's the rejection region that I get? Smaller equals to 16, right? So I will put in x smaller equals to 16 here. Given that null hypothesis is true, what is my null hypothesis? This one. And if it is true, that means p is equals to 0.95. So p is equals to 0.95. That means if you want to calculate this probability, you need to use x is binomial distributed with 20 and also 0.95. And you need to calculate the probability one by one. So x from 0, then 1, 2, 3, 4, 5, 6 until 16. The other way is you can try to find out 1 minus 20, 19, 18, and 17. Okay, so no matter what method are you using, right, you can actually see that this particular value has appeared in our calculation just now. Do you aware that we are having x smaller equals to 16 using the 0.95 for the p? What's the answer here? 0.0195. So you can actually, 159, sorry. So you can actually try to write out the answer directly from the part number A, which is 0.0159, correct to 3 significant figure. Yeah, then after that, let's continue to the last part. Jimmy believed that the true percentage at Arvin's college is 70%. Assuming that Jimmy is correct, find the probability of a type 2 error. Okay, then now let us proceed with this type 2 error. What is the definition for type 2 error again? So the type 2 error definition will be accept the null hypothesis when the null hypothesis is false. Okay, so accept the null hypothesis in calculation means that you have to put in the acceptance region. If rejection region is x smaller equals to 16, acceptance region will be x greater than 16, no equal sign. When they say the null hypothesis is false, that means the p is no longer 0.95 anymore because it is false, right? It should be p smaller than 0.95. But when p is smaller than 0.95, it has many possibility, right? It can be p equals to 0.8, p equals to 0.9, and so on. Therefore, in the question itself, they will give us a new value for the p. So this is the new value for the p. Okay, so from here, I think we will know that p should be equals to 0.70 in this case, which also means that if we want to calculate this particular probability, we are using this distribution. X is binomial distributed with 20 as the n and 0.7 as the p. Okay, so let's calculate the probability now. For x greater than 16 using binomial distribution, I should start from 17 first. So 20C17, 0.7 power 17, 0.3 power 3. Okay, 10 plus 20C18, 0.7 power 18, 0.3 power 2. So 17, 18, include 19 also. And also 20. And let's see, what do we get from here? By right, you should be getting this one, okay? You double check a few times so that you didn't do careless mistake when pressing calculator. And of course, I have to correct it to 3 significant figure. So your final answer should look something like this, where it is equals to 0.107. All right. Yeah, so basically, this is how we calculate the probability, okay, for the type 2 error. Right, and this is the end of the whole video. Thank you very much for watching the video.